Scott, please.
Thank you.
Thanks very much for joining us.
Good to see you.
Great to meet you. Tell me a little bit about yourself in the context of your work.
Yep. So my background is really a combination of nutrition in feed companies for about 13 years, and then transitioned over into technology during the start of the dot-com craze in the early 2000s. So ran a company in the crop agriculture side that was an ERP system and trading system for grain, along with seed ordering, both early stages of what at that time we called ASP, now you call it SaaS. Um, did very early rounds of people, teaching them how to get on the internet with dial-up modems,
Right.
and expanded that through to really one of the first internet-enabled agriculture applications in the market.
All right.
So
Very
that
exciting.
was, yep,
Yeah.
it was good.
Great. So today we're talking about microbiome. Give us a baseline around what the microbiome actually is and why it's so important in the context of poultry health.
Yeah, the microbiome is the ecosystem that evolves within the gut, and there's all different kinds of microbes in the gut and flowing through the intestine that help digest the food, that help protect the immunity system, that really help process what gets broken down, then what gets utilized in the intestine. The other thing that's really important is, we leave the gut and then it goes into the intestine, and that's where the nutrients are actually absorbed, and they're absorbed in different ways and different rates along the whole intestine. So what happens at the top is much different than it is at the bottom. So when we're looking at the microbiome, it's important to, yes, the especially in the poultry, the ceca is the cleanest, fullest, but that doesn't necessarily mean that's what's getting digested. So we need to look at it at all three stages, top, middle, and bottom of the intestine as well, to really understand what's going into the animal versus what's exiting the animal.
Okay. And in that context, you had a sentence basically diversity equals resilience.
Yep.
How does that principle translate to poultry operations in practice?
As you look at the linings, the diversity of the microbiome and the quality of the mucus layer is really the defense against pathogens. So if you have a very weak microbiome and a very thin mucus layer, pathogens very easily invade the intestinal walls and invade your system. With a good barrier, that's our first line of defense in immunity and health is a solid, strong microbiome is what keeps those pathogens at bay and limits the effect of bacterial or viral diseases.
Mm-hmm. And in that context, DSM, they've been always a pioneer in microbiome analysis, and I know that the company has set a strategic focus on this topic.
Yeah.
What's been the trajectory of the technology over time?
So technology started hundreds of years ago. I think 1860s was when the first talk of gene sequencing and dividing out the DNA and understanding the diversity of a gut, etc. But of course, very very elementary. In the 70s and 80s, started to really look at more the gene sequence potential, the capabilities, the understanding the double helix, and that then drove the need for more computing power. One of the things, those of us who were involved or were in the industry back when Cray computing came up in the 80s, that move to supercomputing opened up a whole new world that really in the early 80s machines to do what's being done in supercomputing would take millions of years of processing
Yeah.
time that literally is done in a second.
Yeah.
And so that's the real transformation that allowed all of the gene sequencing capabilities to occur from the human genome in the late 80s, early 90s to where we're at today, sequencing what's in your microbiome to understand exactly what the components are.
And in that context of the computing power, I think right now we're looking at three elements we're basically connecting here. You know, there is the sequencing element, there's the metagenomics,
Yep.
and the AI interpretation of all
Exactly.
of that. How
Yep.
does technology enable us to bundle that into a single platform now?
Yeah, so you've got the ability to understand the sequences, so we can identify things. Now that then becomes kind of like going into the rainforest and finding new insects. You don't know what they are, so you have to be able to classify them and understand what groups they belong in. But then we have to understand what do those groups do within the host. And I think that's really where the industry is today is, and where I think we're really leading it is a lot of companies went to either still the old plating method or moved into the RNA process where you could look at the groupings and say, here's good bacteria, here's bad bacteria, this is good community, bad community, which showed you representative diversity, which, as I mentioned earlier, good versus bad in health status, it doesn't necessarily correlate to performance. And so now what we really got to understand is what do these bacteria do within the body that affects performance, and how, when we feed them, are we changing that, and how that then affects performance. And so when we look at, in our mind, combinations of blood biomarkers, which are really a gold standard with the most research against them, understanding what different blood biomarker levels mean within the animal, and tie that then to the microbiome, we're able, I think, much faster than others to associate then the host interaction of microbiome with blood. Because when we're doing a microbiome sampling, we'll do blood as well. So we understand what the blood's telling us, and then we can understand the microbiome. But the microbiome goes so much deeper than blood. Examples, we could tell with an operation you have an immunity challenge, but I can't tell what's causing that. When I go into the microbiome, I know it's immunity. I can look at the categories that address immunity, and I can find the ones that are out of whack from the rest of the population. So it really lets us solve the final answer in a lot of cases with blood giving us the direction, microbiome giving us the specificity.
And in the context of putting all these puzzle pieces together, you conducted a too complex case study. Give us an idea of that.
So the situation was customer had kind of a systemic problem, two complexes very similar to each other, as you would expect, similar genetics, similar feeding program, similar time of year, so weather patterns, they're very close to each other. But the fall and winter session on one of the complexes would fall off. The growth rate slowed. They weren't able to get the birds up to weight. Percentage of those birds were underweight at the time of processing, and it was costing them money in some cases. Some tens of cents per bird, not pennies per bird, on either added time you have to finish them off, or value of the carcass being light. And so what the real look was, we're doing everything the same. Why are we getting different results? And so we did the blood. We could see that there were some immunity issues. We could see that the poor performing complex was not at the same level of immunity welfare as the other, or a higher level of immunity stress. And so then we brought in microbiome work, and we did microbiome work on not just the birds, where we could show very specifically the association of specific levels of Campylobacter and Helicobacter and the time of the age of the bird that those two were hitting the one complex versus not hitting the other complex. But then matching that with the blood information and looking at divergent glucose levels in the two complexes, you started to see that there maybe is a bit of a hatchery difference between the two, because 7 to 10 day glucose issues are definitely a hatchery hen contribution. They aren't consuming feed that they're going to drive that off of the feed. But then the pathogen hits to those birds. We had two things happen in this one complex that were different than the good performing complex. So as we gather that, and as we assess that, you got to then look into what's causing this. And in the end, in the final discussions with the customer, it really came down to litter management. And the good performing complex is handling their litter in a windrowing and managing the composition of that litter. and the other one was more sterilizing. So they're eliminating everything and starting over every time. And so that incubation of the birds at a young age is creating higher protection for the birds from pathogens and viruses, et cetera, than one where we're starting from scratch every time. So changes in the litter management program, incubating, understanding what your litter is. We do microbiome assessments on the litter. So I think really knowing what your pathogen and your viral load in the litter on every batch of birds is something the industry really isn't doing, but highly valuable to understanding how you're really starting those birds off, and then how you manage those birds if you're going to start them with nothing, or you're starting them with a appropriate load, or you're starting them with a high load. I mean, just the issue of knowing it gives you so much more knowledge on how you're going to manage the birds.
Mm-hmm. And then concretely, that discovery of that there's a difference in litter management, what type of recommendations did you give to the producer?
Actually, the things that were tried was incubating the bad litter, if you will, with the good litter.
Mm-hmm.
So now you're creating the same load in both operations, and so you have a similar litter, and really expect we'll see coming into this year, but really expect we'll see much better performance, more consistent between the two, because you do have same genetics, same feeding programs, same environment. If we can get that start to the birds the same as well, then the ongoing performance should be consistent too.
Mm-hmm. So there's a general shift in that I perceive, right? That we're starting to work with our microbiome. We're starting to work with the organisms that occupy the space in which our animals live, and we're rather looking at a place of homeostasis, equilibrium, rather than saying we need sterile spaces where
Right.
the animals live.
Right.
Yeah.
Exactly. I think that's a key, decision point is people really got to understand what you're starting with in your environment. If you do start with sterile, that's a different program than if you're going to start with a good litter composition, that you understand what you're incubating those birds with. Even into your vaccination programs. If you're starting with dirtier litter, if you will, or higher pathogen loads, you probably need a more aggressive vaccination program on it. So even that plays into how we manage the birds. So it's not just the floor, it's it's not just what they're walking on. They're pecking at it all day long. So they're consuming stuff off that floor as well, and that's going into the birds, and we have to understand what that's affecting, and especially the start. That's the most important part in the microbiome, is that early stage of the bird where they're building that diversity, they're building the immunity, they're building the protection. And if we're shorting them there, it's really hard to catch up. So that's an important part of the management processes. I think people do a good job of keeping clean and doing the sterility or cleanliness aspect of it, but it's really understanding what's left and what you're putting in there so that you can manage and feed accordingly to that.
Are there some general recommendations you can make for producers, or is it rather a very individual matter?
I think it's more individual, because everybody has their own processes of what's important. Europe does more just clean out the barns between every one, which is fine, but then you're starting with much less. So when you put in new bedding material, you really should know what you're putting in there. Whether it's a wood chips or rice or nut shavings or whatever, they're all are going to have different compositions. They're all going to have different pathogens and bugs and such. So you have to know what you're putting in there, and understanding if it's really a sterile environment, that too causes its issues, because then you're not helping the bird with that initial stage of building the immunities from pathogens in the soil that you come from naturally. So I think it's really individual. It's not this is the best way to do it necessarily. It's if you're going to do it these different ways, you got to understand the full contribution of what you're putting into those animals.
And on level of ROI for the producer here, what do you estimate that to be?
The ROI is it's interesting because
Mm.
a lot of the discussions you have with people are that these new things, sustainability and welfare and all, those cost. Most of the time we're not seeing a cost, it actually saves because you're either doing too much that you don't need to do. I mean, sterilizing costs money, so you don't need to sterilize. Well, okay, then that that's not an expense you're going to be paying. So there's an issue or a difference of um, you got to just really understand how the best optimal way to produce the product at the end is versus I'm either going least cost or I'm going maximum production. When we go maximum production, we're putting a lot out onto the ground. It's not all getting utilized by the bird. We're putting a lot of extra that gets processed out of the bird. That's not ideal either. High nitrogen levels going into the soil. We have those kind of contributions. Methane, ammonias, the things that come out of the backs of animals. We can manage that better in the digestion process of every animal, bovine to swine to poultry. So it's really we got to know more about what's in the environment, what's being fed to the animals, and I think that's really the key of microbiome. I can test litter, I can test the animal, I can test a lot of things to really understand what's going to get inside that bird.
And on the level of prediction, then, because the tools like biomarkers, also now in combination with microbiome data, we are for the first time in a situation where we don't have to wait for the animals to display symptoms, but we can potentially act much earlier if we have the data, and we can mainly massively improve our prediction accuracy.
Exactly. Yeah, and our prediction period. A lot of times right now, you just do the same thing and hope you get the same results, and then you didn't, and you got to figure out why. What it really is allowing us to do, the blood biomarkers, especially in the early stage, but I also think, we want high diversity and we want good colonization early in the bird's life from the microbiome. If we don't have that, we know you're going to have problems. So we're going to need to address that through the feeding program and through the health program if we see that early. On the other side, if we see blood parameters that are specific levels and groupings of levels and are starting to move in different ways, we're able to predict the prevalence of both health and nutrition issues. So catching that early and being able to adapt it, you might not be able to get rid of the problem, but you can minimize the impact of the problem. And I think that's the savings value on it. We a lot of times don't understand the cost of mortality. I think that's something that gets lost in a lot of times we're valuing the cost of the medicine, the cost of the hospitalization, the cost of the treatments, et cetera. We're not really understanding the real cost of mortality. And so I think that's something that comes back into the 0.5% mortality gain is real dollars. And so I think that's another part of the awareness of really being able to put values on not just the weight performance, but also keeping those birds alive and into the processor.
That's an interesting point, the cost of mortality. I want to take a little tangent on that. So, cost of mortality, I gather you're saying it's not just total loss of that animal, but there are externalities, there are knock-on effects here, like potentially affecting others because we've let, let's say a viral load or a bacterial load run up really high in that animal. I have to take the animal out, I have to scout for these, I have to, dispose of them correctly. Is that what you're tending?
You have that, but you also have when they die.
Yeah.
Dying at the end, you put your whole investment into it. Mm-hmm. So if you look at your mortality and your mortality is 3% across the flock, if that happened at the end, much more dramatic cost to you than if that happens at 13, 14 days. Mm-hmm. So understanding where this is happening and being able to restrict the effect or limit the effect of those late stage mortality, those are the killers. The early stage lost cost of the burden, a little bit of food, and you're going to have to resupply your quantity commitments from somewhere else. You lose them at the end, it's too late to get them from somewhere else, and you have the full life cycle of the cost of the the feed into them. So,
I understand.
and yes, then infection rates, if you don't catch it early enough, you've got multiple infections. They get to a stage where they really become contributors to the rest of the flock, and you have that whole issue too. Yep.
So then in that context, what's your advice for companies starting to explore microbiome data?
Yep. Understand your baseline, understand where you're at with your, because it's your microbiome is going to be determined by your environment, it's going to be determined by your management practice, it's going to be determined by your feeding programs. All of that's going to affect. So your same bird and your partner, or your neighbor's same bird, they can have exactly the same genetics and exactly the same feed program and have completely different microbiomes. So you can't look at it and say, this is good, this is bad. You need to understand how good microbiome or microbiome community performance ties to your own production, your own formulation, your own health programs. Once you understand that baseline, now every change you make, you can evaluate exactly how that's hitting the bird. You can determine whether what you're doing is positive or negative to the microbiome community. You can determine which of the pathogens or beneficial microbes are actually being grown and succeeding in that environment, and then you can deal with it appropriately. But the first thing, one test is going to tell you, oh, you're good or you're bad, because we have to tie that to the whole production data information. And that's really where we want to work with producers, is all of your information. We help you with the analytics. We help you with understanding what is going on in your total operation. We'll bring these other tools to give you a deeper look at the bird, but you've got to marry it with all the rest of it.
Mm-hmm. Marrying it with all the rest is also important to take this to the level where we can have a day-to-day decision-making tool
Yes.
here, right? Because right now we're at the stage where we do it in trials, we do it irregularly, and then we have an interesting baseline. But this doesn't mean that the farm manager who comes into the animals in the morning actually has microbiome data at his disposal.
Yep.
How do we get to the point where this can flow into everyday decision making?
I think that's with the inclusion of AI.
Mm-hmm.
So you bring back all of the data, you bring back all of the scenarios. We build models that can tell you, with this scenario, this situation, tying all of the information, breed, sex, feeding programs, management, and microbiome and blood data. We see this kind of expected performance, and you're monitoring that. And as you start to see a differentiation, being able to then use AI, simple, chat GPT type system where, I'm seeing this is not happening. My weight is down a little bit. The temperature in the house has been changed a little bit. What should I expect? And being able to go back into the data and then make those assumptions or predictions going forward, so they can adjust either management, feed, time, wind flow, etc. in the house. Those are all the things that I think happen. So we have a system called Lori that is being used in the cattle side of our business. We'll be expanding that into the other species with the intention of that becomes a tool of being that LLM AI tool for people then to just enter, here's what I'm seeing, compare that to all of my data, and we compare to all the research. One of the basic fundamentals of Verax is we use the collection methods to find the blood biomarkers and the panels and the levels, but then we take that and use AI to compare it to all the research out there to show this similar situation was done in this kind of a trial. Here were the results, and this is what you could expect out of it. So we can now start to take research information literally at the fingertips of somebody making day-to-day decisions on the farm.
Mm-hmm. So if we able to implement all of that, what is the next frontier? What does that next frontier look like?
I think the next frontier is, and my hope is really a twin farm, that I can develop electronically a duplicate of people's operations. And so then you can, twist the levers and twist the toggles. And if I change this, what can I expect? If I change that, what can I expect? That we're able to really model production and animals to a level that you can create then expected outcomes of what people. So even before you choose your genetics or choose your feeding program or choose your housing systems or decide that I'm going to change my litter program, I'm going to windrow versus just scrape the tops, all of that will play into the expected performance. So we become much better at being able to achieve what our predicted results are in each one of the batches of birds.
Yeah, that'd be fascinating.
Yeah.
Well, Scott, thank you very much.
Very good.
That was a very interesting conversation.
Yeah, nice to talk.
And I'm looking forward to seeing a digital twin of the farm come into existence.
Sounds good.
Yeah.
Thanks.
Thanks very much.
Thank you.